This is question number 10 of homework 1. So this is the CML, which stands for capital market line. The question related to the capital market line. The market portfolio has an expected return of 11.1% and a standard deviation of 21.1%. The risk-free rate is 4.1%. So if we recall, capital market line depicts is a straight line which connects the risk-free rate. Let's go back to my lecture slides. Connects the risk-free rate. This is the risk-free rate and the so-called market portfolio. All right, so that's tangent on this. This is called a feasible or efficient frontier. Right? So this whole area here is the feasible set, which is obtainable by choosing a certain weights on individual assets within the portfolio. But this is the efficient frontier, which means any point below it will be inefficient. So one of this efficient frontier will be the market portfolio, and that's the point which is tangent to this straight line which connects this risk-free rate. So, and that's what this is about. So you just connect this point. So you see that when you move, you rotate this point around this risk-free rate until that you get to the tangency point. That's the furthest point you can go. Otherwise, if you go even above that, then that's not obtainable, right? That's not feasible because we said this is a feasible set. So this straight line is the so-called capital market line. So this line tells basically the use of this line is simply to tell investors how to invest. If you have the money, how do you invest in the market? So based on this, of course, to get to this point, to get to this capital market line, you have to make some assumptions. But suppose those assumptions hold, then this line tells you that you should choose a point on this line, and which specific point you choose depends on your risk tolerance level. This line itself does not depend on the risk tolerance level of investors. So that's the beauty of this, the so-called separation principle. I will talk about that in this chapter, the separation principle. So let me redraw this in my notes just in order to analyze this question. So that's the background for this capital market line. And horizontal axis here is the risk. Here the risk is the total risk, standard deviation. And the vertical axis here is the return, expected return. So let me just use R to denote that. Sometimes you use E, parentheses, open parentheses R, and close parentheses. Here I just abbreviate it just to be R. So as we said, you have this curve, right? This is the efficient frontier, and you have this risk-free rate. And the so-called capital market line is simply the curve, the straight line, which is a straight line and which is tangent to this efficient frontier. Sorry, I have to use my mouse, so this is not very beautiful. So this is the so-called market portfolio. This tangency point, this is called market portfolio. And if you check the setup, you can find actually the specific location of this market portfolio. The standard deviation here will be the standard deviation of the market portfolio is 21.1%. So this is 21.1%. And this vertical axis here will be the risk-free rate. That's gonna be 4.1%. So that's risk-free rate. And this risk-free rate, sorry, this is not risk-free rate. This is the return. This is the return. Sorry, this should be the return for the. I should erase that first. This is the return for the market portfolio, not risk-free rate yet. 11.1%, and this is 4.1% risk-free rate. So basically, that's what the question is telling us so far. Okay, so now once we understand what's going on, then we can solve this problem. Part A, what is the expected return on a well-diversified portfolio with a standard deviation of 8.1%? So basically, a well-diversified portfolio means that the portfolio has to be on this capital market line. So this is the CML. And you know that its standard deviation is 8.1%. So it's shut somewhere here, I guess. So this is 8.1%. And the question is about what is this return here? Right? What is the expected return on this portfolio? So that is the question. R. What is this R here? That's the question mark. So once we know what the question is asking, then we can solve this problem. How can we solve this problem? We can just use the knowledge from our middle school, probably geometry, right? Because this is the straight line. So you can see that this angle here, the slope of this angle here, has two ways to express this slope. One way is to use a point on this triangle here, this point. And we know that this point, this height will be 11.1% minus 4.1%, right? So that will be 11.1, because that's the distance between the risk-free rate and the market return, minus 4.1. So that gives me 7%. And that's this, basically, I believe this is called wrong, the wrong of this triangle, right? Or I call that height sometimes. The height of this triangle, 7%. And this base, so this is the base here, obviously that's given. That's basically the standard deviation of this market portfolio. So that's 21.1%. So one way to express the slope of this angle is simply the wrong divided by this base. And the wrong is 7.7%. And the base, 21.1%. So that's one way. And another way is to use a point here, because we are trying to solve out this expected return for this unknown portfolio, right? But we know that the portfolio here has a standard deviation of 8.1%. So we know that. So that means this base, once we take this triangle, the base here is 8.1%. So that's my denominator for the slope. That's the base. And the run, if I use the triangle, this smaller triangle here, the run will be R, right? This unknown expected return for this portfolio minus this risk-free rate. Let me just directly plug in the number. Okay, just save one step. So risk-free rate is 4.1%. So this whole thing here is another way to express the slope of this triangle, because they both this bigger triangle here, slope of this not triangle, this angle, because the bigger triangle here and the smaller triangle here, they both give me the same slope, the slope of the same angle, so they must be equal to each other. And you can see that once we understand what's going on, we basically has generated a linear equation with one unknown. So we can solve out this R. How do we solve out? We just first we multiply both sides by 8.1%, right? So then we can get rid of the denominator here, and then we switch sides. So we get now the left-hand side becomes R minus 4.1%. That equals 7% divided by 21.1%. And then times 8.1%. So next step is to simply move this 4.1% to the right. So then when we move this one number to the other side of the equation, we have to change sign, right? So then we R equals this 7% divided by 21.1% times 8.1% plus 4.1%. So then we can use whatever tool we have, calculator or Excel, to figure out this final number. So let me just use my Excel. So this is 7% divided by 21.1% times 8.1% plus 4.1%. So this gives me, you have to be careful about a rounding requirement here. Do not round intermediate calculations. And that's why I kept this whole chunk rather than this whole chunk, rather than just calculate its value, because I don't want to round the intermediate calculations. And finally, enter your answer as a percent rounded to 2 decimal places. And here Excel, you can see it's in decimal format. So I want to change this to percent format. How do I do that? I right click on the cell and then click format cells and then choose the percentage, and then decimal places I choose the default 2. Okay, so that gives me 6.79%. 6.79%. Okay, so and then that's part A. Part B, what is the standard deviation of a well-diversified portfolio with an expected return of 19.1%? So this part A is that given the standard deviation, what is the expected return? But part B is switch the unknown. Now we are given the expected return. We need to figure out what is the standard deviation. So that's the only difference. But the trick to solve this part B is exactly the same as that for part A. So I just need to going back to the same. Looks like this is sometimes, I don't know, my office is not working properly. Sometimes I just trying to figure out the reason. But that's the, let me use the red pen just to differentiate it from the other point. So now we know the return here is 19.1%, right? 19.1%. And because the market return is 11.1%, so 19.1% has to go above that. So you can see that the point has to be somewhere here. Suppose this is the 19.1%. So the scale may not be perfect, but you see what I'm trying to see. You see what I'm trying to explain here. So now the unknown becomes this sigma. What is this sigma? Question mark. But the trick is the same. Yeah, still we focus on this slope of this angle. So one way to express this angle is using the market portfolio, and that we have expressed to be 7% divided by 21.1%. Now the second way is to use this bigger triangle. This triangle here, let me use that. This triangle here, this triangle. So this triangle, see that return is provided. So the wrong of this triangle is 19.1% minus 4.1%. So that gives me 15%. Again, this 15% is calculated by taking the difference between this return and the risk-free rate, which is 19.1% minus 4.1%. So that's why we have that 15% in case you missed that part. And then the base is this unknown sigma. So now let me simply erase this. So just save some writing because I'm using the mouse. So it's not very easy to write. So 15% divided by this unknown sigma. Okay, so now how do we solve out this equation? You can just erase this first. How do we solve out this equation? Now the unknown sigma here is in the denominator. So but generally we don't like a variable to be in the denominator. So we want to change the denominator to be the numerator. How do we do that? Remember, this is an equation. So if we want to switch the denominator and the numerator on the right-hand side, we have to do the same on the left-hand side. So the equation will become 21.1%. So now the left-hand side, the denominator becomes the numerator divided by 7%. And that equals this unknown sigma divided by 15%. So now you know how can we, you should be able to figure out how do we solve out this unknown sigma. Then we can just multiply both sides by this denominator 15% and then switch sides. Then we can express sigma to be 21.1% divided by 7% and then times 15%. So, and then we can just use the Excel to figure out the answer. 21.1% divided by 7% times 15%. So again, have to note the rounding requirement. Do not round in the intermediate calculations which we did. Can enter your answer as a percent rounded to 2 decimal places. Again, keep this as a percent. So we have to use percentage and keep 2 decimal places and OK. So that gives me 45.21%. 45.21%. So now let me check my answer. Okay, good job.